Hey guys, this is Space Train, your daily express till the edge of the space, and today we will talk about, what is the gravity? Grab your tickets and let's go. Don't forget to subscribe to get unlimited pass on our expedition. Gravity is the force that attracts two bodies toward each other, the force that causes apples to fall toward the ground, and the planets to orbit the sun. The more massive an object is, the stronger its gravitational pull. Gravity is one of the four fundamental forces, along with the electromagnetic, strong and weak forces. It is what causes objects to have weight. When you weigh yourself, the scale tells you how much gravity is acting on your body. The formula for determining weight is, weight equals mass times gravity. On Earth, gravity is a constant 9.8 meters per second squared, or 9.8 meters/s2. Historically, philosophers such as Aristotle thought that heavier objects accelerate toward the ground faster. But later experiments showed that wasn't the case. The reason that a feather will fall more slowly than a bowling ball is because of the drag from air resistance, which acts in the opposite direction as the acceleration due to gravity. Sir Isaac Newton developed his theory of universal gravitation in the 1680s. He found that gravity acts on all matter and is a function of both mass and distance. Every object attracts every other object with a force that is proportional to the product of their masses and inversely proportional to the square of the distance between them. The equation is often expressed as Fg equals g, m1 asterisk m2, r2 Fg is the gravitational force. m1 and m2 are the masses of the two objects. R is the distance between the two objects. G is the universal gravitational constant. Newton's equations work extremely well to predict how objects such as planets in the solar system behave. It's great that when Apple fall on Newton, he asked the question why did it fall, and made great theory about gravity, instead of making iPhone, but there was a problem. Bendis Paradox is a cosmological paradox pointing to a problem occurring when Newton's theory of gravitation is applied to cosmology. Richard Bentley was a younger contemporary of Isaac Newton. After Newton had formulated his law of gravitation, he observed, in a letter to Richard Bentley, that if all the stars are drawn to each other by gravitation, they should collapse into a single point. One will be drawn to another, that star will grow and pull in still more and more. In time, everything must be drawn in. According to Newton, each star in the universe ought to be attracted towards every other star. They should not remain motionless, at a constant distance from each other, but should all fall together to some central point. Newton admitted as much in a letter to Richard Bentley, a leading Cambridge philosopher of the time. Newton solved the paradox by claiming that God prevented the collapse by making constant minute corrections. Though Newton's explanation was rather unsatisfactory from a cosmological aspect, Bentley's paradox could prove to be the reason behind the Big Crunch, the opposite phenomenon of the Big Bang. In your face, Newton. And once again we come to theory of relativity. We talk about this in our other video, you can check link down below, or click on left side above the screen. If you are lazy, I will explain a little bit. In Newton's universe, space is a flat and empty place that objects like stars and planets move through, but Einstein took a different approach. In one of the towering scientific achievements of the 20th century, Einstein and his former professor Hermann Minkowski showed that space and time are not separate entities, but rather a single four-dimensional continuum. They imagined it stretching through the universe like a fabric. We also made a video about this, and you can check link down below. Any object with mass, Einstein reasoned, would interact with the fabric of space-time and cause distortions. As a classic analogy goes, imagine space-time as something like a trampoline. A bowling ball placed in the middle would bend the fabric and create a well. If you then set down a marble near the bowling ball, it would spiral around the well as being pulled inwards, much like how the Earth orbits around the Sun. Einstein's theory of general relativity therefore describes gravity as not just a force, but geometry, It is a consequence of how matter warps space-time. Good for us that Einstein was not banned for copywriting claims for using similar content, and seriously, check the link about relativity, to find out more. Okay, let's check some interesting facts about gravity. Number 1. The gravity on the Moon is about 16% of that on Earth. Mars has about 38% of Earth's pull, while the biggest planet in the solar system, Jupiter, has 2.5 times the gravity of Earth. Number 2. Though nobody discovered gravity, legend has it that famous astronomer Galileo Galilei did some of the earliest experiments with gravity, dropping balls off the Tower of Pisa to see how fast they fell. Number 3. Isaac Newton was just 23 years old and back from university when he noticed an apple falling in his garden and began unraveling the mysteries of gravity. It's probably a myth that the apple bonked him on the head though. Number 4. An early measure of Einstein's theory of relativity was the bending of starlight near the Sun during a solar eclipse on May 29, 1919. Number 5. Black holes are massive collapsed stars with such strong gravity that even light cannot escape from it. Number 6. Einstein's theory of general relativity is incompatible with quantum mechanics, the bizarre laws that govern the behavior of the tiny particles, such as photons and electrons, that make up the universe. And the biggest question, mass or weight? Mass is the stuff that matter is made of. People often confuse mass with weight. But weight is actually the result of gravity pulling on the mass. Gravity's pull on an object decreases with distance from it. So, a climber on top of Mount Everest weighs a little less than at sea level. If a spaceship travels far enough from Earth, it will eventually escape Earth's pull completely. We measure mass in grams. We measure weight in ounces and pounds. Your mass would stay the same if you could travel from planet to planet, but your weight would vary depending on how the gravity of that planet pulls on you. I will drop a link to a website where you can check how much you will weigh on other planets. There are lots of questions left, so don't space out, and leave some space in your brain for answers. I hope you enjoyed this video. If you want to see more, subscribe and click the bell button, to get notifications on our latest videos. If you are still here, grab your knowledge and get out of my train.